If you see a railway, chances are there'll be more than one track. Multiple tracks can run next to or adjacent to each other. Trains pass each other on these adjacent tracks as a matter of course every day. Keeping them from hitting or striking each other is managed through the process known as gauging, and also maintaining the distance between the adjacent lines, known as the track interval. There is one area that the track interval, or distance between the tracks, is intentionally reduced. This is around switches or points. Switches or points are the parts of the track where trains can change tracks. This means that two tracks come together, reducing the distance eventually down to zero, along with the passing clearance. As these two tracks get closer together, there is a chance of a train sustaining a glancing blow or a full-on collision with another. So, how are trains kept safe around junctions? This is where foul and clearance points come in. Both are theoretical lines on a junction layout, but with slightly different meanings. Let's start with the fouling point. If an object is described as foul of the line, like this tree, it will be hit or struck by a train as it passes. This can be because it lies across the track, or close enough to the edge of the track, given that the train bodies overhang either side. The fouling point is the line that, if crossed by the train, would mean that that train was foul of the adjacent line, therefore could make physical contact with another train passing on the other line. The clearance point is further back from the junction than the fouling point. In our next section, we'll look at why this is and how the location is calculated. So how do engineers determine where the fouling and clearance points are? Let's work out the fouling point on our junction here. In the UK, the fouling point is taken as 1,970 millimetres between the running edges of the rails, measured at right angles to the track. 1970 is what is known as the standard track intervals that designers and engineers aim to achieve and maintain between adjacent lines. To ensure both lines are equally protected, the measurement is repeated on both lines, the endpoints, and then joined to form the fouling point line. So next is the clearance point. There's two measurements to consider here, the safety margin and the vehicle overhang. The vehicle overhang is the distance between the nose or front of the train body and the first axle. But why is this important? Track circuit and axle counter signalling systems, both used to determine the position of a train to a signaller, use the train's axles to detect the train entering a section of track. Track circuits do this by passing a current from one rail to another through the axle, while axle counters count the axles in and out of the track section. But the train nose, and not the axle, are the furthest forward part of the train. Given that the clearance point can be used to locate parts of the track circuit or axle counter systems, it's important to make sure the difference between the location of the axles and the nose is factored in. The UK standard gives a distance of 5,860 millimetres to be used as the distance from the fouling point to the clearance point. This is inclusive of the safety margin and the overhang. This figure covers all rolling stock used on the network and would have to be considered when introducing new designs of trains. One other key point to remember when it comes to the location of fouling points is that if the lines become parallel, the fouling point is placed at the point the lines become parallel, even if the distance is not 1970. The management of the interactions between the two trains from this point on is controlled via gauging and passing clearances. The distance for the clearance point is the same, but the line to the clearance point for line 2 is taken as shown. Similarly, on the approach to a junction where the lines are parallel, such as a crossover, the fouling point is taken as the toes of the switch. This is because the toes of the switch is where the path of the train on which an otherwise controlled track interval starts to change as it diverges from line 1 towards line 2. So, to sum up, clearance and fouling points are key to avoiding trains striking or colliding each other around railway junctions. The fouling point is placed where the interval between the two tracks is 1970 millimetres. The 2 points are required to take into account the location of the wheels in the train body, as well as factor in a safety margin, and are 5.86 metres apart. I hope you've enjoyed this video. If you want to know more about railway engineering, a great place to start is with our Track Components Guide ebook that is available at the link in the description. If you want a little added extra, by signing up to our email list today at the link below, you'll get our free Guide to Cant ebook straight into your email inbox. Do drop any comments or queries below, hit that like button and subscribe so you don't miss a single video. Thank you.